Hey guys, let's go over this worksheet. Mr. Ng and 11,620. Baseball coach graphs some data and finds the line of best fit. So the best line of best fit is also called the line of regression. The equation for the line of best fit is y equals 0.32x minus 20.51, where, okay, x is number of times at bat. So we're playing a game of baseball and you go up and take the bat and try to hit the ball. So that would be the x variable. And y is the number of hits. Okay, how many hits? Okay, this is the question, so that's what we're trying to solve for. Y is the number of hits. Should he expect from a player who is at bat 175 times? So I'm going to write down this equation again. And at bat 175 times is x, so x is equal to 175. So I'm going to put in here 175. So really it's a prediction, right? And when you multiply 0.32 times 175 minus 20.51, you will get an answer of 35 hits. Number 1 is A. Okay, number 2. Below is the table of data regarding the cherry blossom trees in Washington, D.C. Make a scatter plot of the data. So let's go ahead and do that. If I look at my numbers, I see a range in the x's from like 1 to 6. So I might go 1, 2, 3, 4, 5, 6. And then for the y's, I see I have a range of up to 25. So I might count by, I don't know, 6, 12, 18. It worked a little bit low, but 24. So this is the, and we're just answering the question, what is the correlation? So I just need to kind of graph it. So let's graph 1.5, 28. So this would be 30. So each of those lines are 3, so that would be 27. Okay, 5.8 and 3. And then 2.4 and 25. 4 and 21. 4.7. So close to 5. And 14. 3.2, 20. And 5, 6. So there's my line of best fit, or my regression line. So I think that would be B, negative. Number 3. Chang wants to know if he is improving his skill on the cello. He created a scatter plot and drew a line of best fit. If he uses the points 2, 8, and 5, 1.5 from his line, which equation would represent the line of best fit? Okay, so I give you guys a hint. Okay, the first thing I said was the Y-intercept here in green. If you look at our graph, this is the Y-axis, and so you're asking where does it cross? I don't know, somewhere up there. So I'm going to guess somewhere near 12. Okay, so the only graph that is possibly close to has a y-intercept of 12, you don't even have to, is A, right? But let's prove it, because then I gave you the formula for slope, which is y2 in purple there, minus y1, x2 minus x1. So I'm going to label these. Did it again. x1, y1. The ones that represent the first order pair, and this is the second order pair. Let's see if we can do some magic here. Just going to copy, paste it down here. Okay. And now we can use that. So y2 is 1.5 minus y1 is 8 all over x2, which is 5, minus x1, which is 2. So I'm going to subtract this and then divide. So 1.5 minus 8 is negative 6.5. 5 minus 2 is 3. So then my slope is divided by 3, and I get negative 2.1667. Okay, so that means my slope is negative, if you rounded negative 2.17, you have that one here, and you have that one right there. Okay, and then again, we chose this one because the y-intercept is around 12. That's my b value. Okay, number 4. The graph below shows a relationship between the distance in miles of a delivery truck. So there's my x down here, and the number of hours each delivery took. Okay, so as miles that the delivery truck goes increases, that means the number of deliveries, or how long it takes, also increases. Okay, just wanted to put that out there. Let's answer the question. Which of the two given points would be best to use to calculate the line of best fit? Well, this line of best fit is the regression line, and regression is the letter R. So I want an R value that equals a positive 1, which means it's a perfect line. So I want these points to be on the line, okay? So let's go through these. How about this one? 511. That's too far off. Let's try 309. So it'll be that point. No, too far off. Let's try C. 409. Not on the line yet. Let's try this last one. 307. Ding. Let's check the other one. 610. Ding. So I would love to use the last one. So my answer is 4 is D. Number 5, Jared collected data on the ages and heights of random sample of elementary school kids. So he plots the data on a scatter plot. Okay, so X is ages, 0, 5, 10, 15. And then over here is height. How tall are these guys? 2, 4, 6 feet. What's most likely to see between age? Okay, so I think little kids are short, and as you get bigger, my daughter's getting taller, so this kind of represents a positive. correlation. Number 6. The graph shows the weights of dogs and the time it took the same dogs to complete an agility course in seconds. Okay. So which line shows the line of best fit? Okay, so I would expect, here's the hard part. If you guys don't know, little dogs, agility is the ability to move, or maneuver, right? They're really quick. They kind of run through those little cones. And so the smaller dogs are actually better at that. Okay, so let's take a look at this. And if you look at it, all of the points are exactly the same. So you're kind of just picking which one goes through the line the best, okay? So let's make a comment about some of these, okay? The line of best fit, this one here is, let's just highlight it. This line right here is too high, okay? And how about this one over here? This line of best fit is what? This one's too low. And how about this one? Whoops. This one's good. I like it. We're supposed to use red. Try to use different colors. Because the line is what? In between. In between. So points in between the regression line, or the line of best fit. Line of best fit. That's what you want, right? And okay, how do I write this? No, right? Regression lines have slope to it. This one has no slope. That would be bad. So our answer is, where's my colors? There it is. The answer is C for that one. Okay, that was 6. Number 7. High school principal wants to predict the number of students who will drop out of school so he can get funding for support services. Hope that never happens. He determined the equation that represents the data as y equals negative 10x plus 216. Okay. Let's get a couple of things here. X represents this X right there represents the year since 2004. Okay, so what I've done here is, okay, this is the X, and you're not going to graph the order pair 2004, comma 217. And what I've done here is I've highlighted years since 2004. Okay, so think about it this way. Let me switch colors here. And I give you a hint here, continue the table. Okay, so what are you going to do is, think about it. 2004 plus 0 equals the year I want to start with, 2004. Okay, so if you keep adding, I should put it the other way. (2004) plus 0 gives you 2004. 2004 plus 1, the 1 year represents 1 year from 2004, gives you 2005. So if you just continue on, you'll notice, right, 2004, kind of all the way down, and then we're trying to reach 2012. Right, this is 8 years since. It says use this equation to help them predict the number of students who will drop out. Okay, so you can't use your traditional we can't use our traditional just like first and second column difference, because although it is linear, it's not perfect. Watch. This is minus 15. This is minus 3. Do you see that? There's no pattern, but generally it's going to have a slope of negative 10. So let's write the equation again. Y equals negative 10x plus 216. And we said that the x values here represent the years since 2004. And the student, so x represents years, okay? And use this equation to help them predict the number of students who will drop out in 2012. Okay, so that's a year, and that's what I want. Okay, so normally you would think, okay, 2012, I'm just going to use this number. But remember, what number you're putting in here is number since 2004. So we're going to put in 8. And if you did your math here, you're going to get negative 80 plus 216, and you're going to get a value that is 136, okay? So our answer is letter choice C. Now, I want to show you guys a common mistake for students. And a common mistake would be to put in here, so let's write up here, wrong. What would happen if you did put in there 2012? Let's just put it in there and see, right? So you would get negative 20,120 plus 216, and if you add those together, you're going to get negative. Put that in my calculator. Negative 20,120 plus 216. And this would give you negative 19,904. Okay? Okay, not only is it not one of my options, just think about it. In 2012, are you going to have negative, says y is the total number of students that drop out, right? Are you going to tell me that negative 20, almost negative 19,000 students dropped out? That doesn't make sense, right? It would have to be a positive number, and you know, give yourself a visual. You'll eventually see that it has to be on that blue line. If not, you're kind of saying negative 19,000 is way down there, and it wouldn't make sense. Okay. Okay, number 8. Which graph represents a positive correlation? This is none or no correlation. This is a quadratic relationship. This one's positive, and this one is negative. So I'm going to go with choice C. Number 9. The scatter plot below shows the average yearly consumption of bottled water by people in the United States starting in 1990. Okay. So again, I want to put this out there. If you say years since 1990, we can start at 0. So what I'm trying to point out is that you could have had a graph that looked like this. 1990 plus is 4, 6, 8. And the reason why is that those numbers are easier to work with. That's all. Okay, don't forget you have the earthquake to show you that there's no numbers between 0 and 10. Okay. Using the line of best fit, predict the average consumption of bottled water in the year 2000. Okay, so we have no equation here, and you can just go to 2000 and see where this line intersects. So I'm assuming the prediction here is on that point. right? So 2 lines would be 20, so 19 is your answer. D is the correct answer. Number 10. The table shows the sales of a flour company for the years 2000 through 2012. Answer the given questions about this table on your answer sheet. Okay, so graph the data on the scatter plot and draw a line of best fit, or the regression line. So let's do that. Okay, so we're going to do, I'm going to use, I'm going to graph that here. So remember, I gave you a hint here, and x equals 0 is years since 2007. Years since 2007. Well, how many years is it since 2007? Don't think of 2020, just think of 2007 is 0 years. And what I'm trying to point out here is that this is 0. And I'm going to count by 2s. Two boxes. And I'm going to title this years since 2007. So this 0 plus 2007, this would be 0 plus 2007 is 2007. 1 plus 2007, that's year 2008. Let's just write that underneath so you don't get... And does that make sense why? Let's just write that. Because it's since 2007, right? 1 plus 2007. 2 plus 2007 gives you the 2009, okay? All right. Let's do the sales there. All right, sales in thousands. And I look at my numbers there and I see 420 to 300. So let's do an earthquake. And let's just do 300. And let's just count by tens. So 310, 320, 330, 340, 350, 360, 370, 380, 390, and 400, and I think there was a 410. Okay. All right, so let's just go ahead and graph this. 305 and 330. Just think of these as order pairs. 2, 345. And 370. 4, 395. And 5, 420. So we have something like that, right? Okay. D, write an equation for the line of best fit for this data. Let X represent the years since 2007, which I showed you in blue there. And Y represent the sales in thousands of dollars. Take a picture so that I can input our data. Okay, so let's go ahead and write an equation. And I'm going to show you guys how to do that again with the graphing calculator. And I have here the directions for the graphing calculator. And lesson 2.6 is creating the regression line using technology. And The best one is just using graphing calculator. Okay, so the first thing we said is to enter the x's into list 1. So you just press stat and then edit. Whoops, stat and edit. Okay, now I have a bunch of lists, and you just go up to that where it says L1 and you press clear, enter, and then I'm just going to type in those numbers. Now again, you are not putting in 2007. You are putting x equals 0, 1, 2, 3, 4, and 5. Okay? And you're going to go up to list 2, and you can do a couple things. You can write over this. It's not wrong. Watch, 305, 330, 345, 370, 395, and 420. Okay? And then I put that in list 2. Okay, next it tells you to go to stat, calculate. And here you can use either 4 or 8. Does not matter. I think I told you guys to use 4 or... Okay, so this is not exactly TI-83 or graphing calculator by Texas Instruments, so you can see it. LinReg is just number 5. In mine, the screen I'm showing you, there is no difference between 5 and 9. The only difference is what is the slope and what is the Y-intercept. Okay? Remember, slope is in front of x. That's just the big idea. Okay, nice thing about this calculator here on my iPad is that it kind of tells you what you need to kind of write. So now we need to write down the list. So that's yellow under 1. So I'm going to have to press second 1, comma, second number 2. And you can press enter. Okay, so there is my equation, and there's a regression, and we'll talk about the coefficient determination later, but that's what we needed. Okay, so here's my equation. I have y equals ax plus b, and we said that a is 22.7 and b is 304.05. So if I just put in this information right here, this would be 22.7, and this one in red would be 304.05, and the remaining y equals 22.7x plus 304.5. And I want to double check that my slope is the number in front of x, and it is positive, right? And you can see that our graph above was positive. Okay? C, according to your equation, in what year, so I'm going to highlight that, in what year? So year there, if you look at it, is it the x or the y? Well, if you don't know, the x's shows years since 2007, and y is sales in thousands of dollars. So this is kind of like money, right? So what I'm trying to do here is point out that this is saying in what year. Year is an x value. Will you reach $500? So notice that it's too high on my graph to estimate. This is the extrapolation, right? It's too high. I don't feel confident because it's outside of where we're at. So, but you can use the equation here. So we're trying to find an x value, okay? And I want to point out, let's see what color I can use, green. In what year will the sales reach 500,000? So this was the, let's use blue. That was the y-axis, right? That number is 500. 22.7x plus 304.05. And then we'll just use our algebra to solve for x. Subtract 304.05. And you will get 195.95 equals 22.7x. And then you're going to divide by 22.7 on both sides. This will equal 1, so x is approximately 8.6. Remember, what does 8.6 remind you in context? Well, it is a year. In year, 8.6. Okay? But since that's 2007, right? So 2007 plus 8.6 kind of gives you in kind of super year 2015.6. Okay? And which one is closest to that in our multiple choice here? That would be B. Okay? So a lot of work for that question in multiple choice, but you need to start practicing how to write those equations with technology. That's what we've been seeing quite a bit. Okay, number 11. I told you to skip this one. You can just skip this video, but I'm going to work it out really quickly. So if you wanted to know, I'm just going to use y equals mx plus b. And the b value represents the y-intercept. So if you look at here, this line is 55. So I'm going to guess 56 or 57. So I believe it's above. So I'm actually going to say the answer there is just D. Now, that was just eyeballing it. So the next thing they want us to do, if you did this one, is just using slope, right? x1, y1, x2, y2. And you would just get slope to be y2 minus y1 over x2 minus x1. And let's just plug in numbers, plug and chug. Y2 is 90 minus y1, which is 65, all over 25 minus 7, which gives me a slope of 1.388. Okay? Or slope is approximately 1.4. So which one of those has 1.4? Well, you have one of these. Okay, so it's not going to be not D, not C. And then again, go back to your y-intercept. I said 50, higher than 55, but in this case, that would be, whoops. Hoi. That would be A. And then question number 12. Which relationship is shown by the scatter plot? Okay, so what do we have here? We have a try that again. We have a negative correlation. So as membership, I like to put numbers to it, as memberships increase, or you can write it like this, as memberships increase, what is happening to our number of new gym memberships sold? Are the numbers going up or down? The numbers are going down. Okay, let's think about this. Think about this in real life. Cost of a gym membership. Let's just say your membership costs you $100 a month. Do you think many people are going to buy that? No. But if you sold it at maybe $1, I think a lot of people would buy it. Okay, so let's go through these. As the cost goes down, the number of, so this is saying as it goes down, now down is just going the other direction. also goes down. That would be wrong. As the cost goes up, the number of sold goes down. That is correct. As the cost goes down, so you're in some ways, if you want to say cost, you're actually going from right to left. The number of sold remains the same. Oh, because that would just be a constant. And they're saying there is no correlation, so that would be wrong. So last answer is B is our final answer. Hope that was helpful. See you guys.